Now on to force. Inertia is the reluctance of a body to change, whether it is moving or not, and it is related to its mass. Once the inertia has been overcome and the body is moving, the momentum of the body is a product of its mass multiplied by its velocity. The mass of a body refers to the amount of substance that it is made up of and is measured in kilograms. For example, a rugby player consists of muscle, mass, bones, and fat, etc. And all of the body parts put together would give the player a body mass of around 110 kilograms. With inertia, a body with a large mass will require a much greater force to get it moving compared to a smaller body or object. In addition to this, a body with a larger mass will require a greater amount of force to slow it down compared to a smaller body or object. An example of this might be two cyclists cycling the same bike. One cyclist's mass is 75 kilograms and the other is 100 kilograms. The cyclist with the lightest mass would therefore need to apply less force through the pedals to get it moving. Momentum is a measure of the amount of motion a body has and is measured in units of kilogram meters per second, minus momentum, which equals mass times velocity. Momentum is important in sports such as American football, basketball, and rugby, where contact and collision are involved. The more momentum a player has, the harder it is to stop that player. Now on to Newton's laws of motion. Sir Isaac Newton stated that there are three laws that help to explain the relationship between force and movement. The first law of inertia states that a body continues in its state of rest or uniform velocity unless acted upon by an external force. This is also known as the law of inertia, and it means that something will either stay still or stay moving unless a force acts on it. For example, a golf ball or a football, which will remain still unless some force is acted upon it to make it move. Hit with a golf club or kicked by a player. According to the first law, the golf ball or football would continue to move at a constant velocity unless something's acted upon it to slow it down. For example, a golf ball might be slowed down by the friction by wind, or football slowed down by the friction of grass surface. The second law of acceleration states that when a force acts on an object, the rate of change of momentum experienced by the object is proportional to the size of the force and takes place in direction in which the force acts. If I use the example of the golf ball being hit as an example, which I just said, this would mean that the change of momentum would be proportional to the size of force acting upon it by a golf club. For example, a golfer on a tee would hit the ball harder with a drive to send the ball as far as possible along the fairway as he could or she could. However, if a golfer's ball was just of the green, she would use a wedge to chip the ball closer to the hole. This is a softer shot and would involve a slower change of momentum. Newton's second law of motion can be expressed as force equals mass times acceleration. And the third law of reaction. For every action, there is an equal and opposite reaction. This third law is sometimes referred to as the law of reaction. For example, when a tennis player hits a ball, the racket exerts a force on the ball, and the ball exerts an equal and opposite force on the racket. The racket exerts what is known as the action force, and the ball exerts the reaction force, which is felt by a player in the increased resistance at the time the racket strikes a ball. When the same ball hits the floor, it exerts a force of the floor on the floor, and the floor exerts an equal and opposite force on the ball. Force and effect. A force is a push or pull that alters the state of motion of a body and is measured in newtons. A force is required to make a stationary body move, change speed, direction, or stop. In sport, an internal force is one which is generated within the body, which could be, for example, the leg muscles contracting to move the bones of a cross-country runner to make the legs move in a forward direction. An external force is one that acts outside the body, for example, a karate fighter landing a kick on an opponent. A total force is the sum of all the different types of forces contributed by each body part in action. A net force is the sum of all the forces acting on a body. If the forces are balanced, then the net force is zero. The body will not move or change velocity. If the forces are not balanced, the net force is non-zero and the body will move in the direction of the net force. Balanced force is an example of balanced force might be an athlete standing still before the start of the race. The downward and upward forces are the same and therefore balanced. An unbalanced force. Two karate fighters in a martial arts fight will show examples of unbalanced forces. Raising a leg whilst balanced and poised on the other leg will offset and unbalance the karate fighter. As a result, the forces going through either leg whilst balancing and simultaneously kicking will be unbalanced. Vertical forces. The vertical forces acting on an athlete are weighed and using mass times acceleration due to gravity and the ground reaction force. Vertical forces are weighed, acting downwards from the centre of gravity, and the ground reaction forces acting up at the contact points of the feet. Direct force and eccentric force. Direct force is when the line of force passes through the centre of mass of a body, resulting in linear motion. For example, a shot putter applies the force directly through the centre of mass to an object, causing the shot put to produce linear motion in a curved line. An upwards trajectory to its peak, and then a downward trajectory to complete the curve. Eccentric force. A force is a force that does not pass through the center of gravity of the body on which it acts, or through a point at which the body is fixed, such as force produces translation and rotation. A tennis player uses eccentric force to position themselves to return a shot, rotating the hips and shoulders and moving the legs up and down to generate power through the shot. Impulse. Impulse is simply a measure of the force applied for a specific time. Impulse equals force times time and has the units newtons per second. It is an important concept in sport because many techniques, particularly throwing activities, require the performer to apply as large a force as possible for as long as possible. A cricketer, for example, has to throw a ball back towards the decreases once a ball has been hit. The cricketer can apply impulse force through holding on to the ball for longer and maximising the force applied when letting the ball go through moving the arms faster. Less impulse force would result in a throw landing short of the intended target. A basketball player will be able to throw a ball further with a faster arm movement and a longer hand connection with the ball. Stability and instability. Stability is all about enabling an athlete to hold a position and stay balanced whilst performing a sporting activity. By training and performing specific exercises, an athlete can improve the firmness of balance and stability whilst performing static and dynamic movements. The centre of mass, centre of mass and location. The centre of mass is simply the middle of an object. The centre of mass is also referred to as the centre of gravity. For example, in the human body, when standing with arms hanging by the side of the centre of mass is at about the top of the hips, as shown by the dotted line in the first image. If you redistribute a mass, its centre or location of it will move. In this example, by moving the arms above the head, the centre of mass is now higher and more about round the bottom of the rib cage. Base of support. A base of support is whenever the body touches the ground. It's called the base of support because with gravity acting straight down at all times, we have a base of support created whenever we are in contact with the ground. For example, if performing an activity for strength and conditioning such as a squat, the base of support would be in the area from the outside of one foot to the other. Another example could be illustrated using a press up. This would be a large area of support from the outset of each hand as well as the outset of each foot. The line of gravity. The line of gravity is an imaginary vertical line from the center of gravity to the ground or surface the object or person is on. The closer the line of gravity is to the center of the base of the support, the better balanced the person will be to the position, and this is seen in the second image. Reducing or increasing stability. Stability can be improved and increased by lowering the center of gravity. For example, when a tennis player is about to make a return shot, they bend their knees and widen their stance. This enables them to lower the center of mass and improve the base of support so they have more control when returning a shot. Stability can be reduced when an athlete is forced to lose balance if they are pushed or pulled in a direction where their center of gravity is shifted closer to the edge of their base support. For example, an example of this might be a martial arts fighter who is forced on to a back foot or a leg which has been raised to perform a kick. The base of support has been shifted to 1 foot and the fighter may lose stability and balance and fall over.